Good morning. My name is Claudio Vita. I am working as a solution architect for Oracle, and today I would like to share with you the experience that we made with the Archeological Park of Pompeii, and discuss a bit how the API, the role of the API in this project, and how the API API Gateway was really important for us in order to to implement our solution, and how he helped us a lot also in the development. So let's start from almost more than a year ago. Basically, well, as you know, right now we are still under the strike of the COVID-19. But basically, before the summer of 2020, the Archeological Park of Pompeii, like others heritage sites in Italy, decided to reopen its doors before before the summer, because well, at that time the pandemic was still there. But well, we started to see the diminution, the decrease of the affected guys. So basically, they wanted to open just to also give a message that we are going to overcome the pandemic. But of course, the first thing to guarantee was for the park was to enable the tourists to have a safer way to explore the Pompeii archaeological site. So prioritizing the social distancing as main tool while you are within the park. So for achieving this goal, the park decided to create a mobile application that worked like the typical tourist application, with for providing guided tours with real-time map, like the point of interest, the facilities that are available, and some other information just at within your finger. But additionally, they want to also to give through the application some information about the people along the track that they are following, how many people were within the site, just to avoid crowds and any potential issues due to the fact that too many people are within the site. So they decided to create this application, and this application was a completely cloud native application built using the Oracle Cloud Infrastructure Service. So as you have seen with the real-time map, along with the track that showing the track, it also provide information about how many people are on the track. So if there is safe to go on, or instead it's better to step down a bit. The application itself, of course, is also integrated with the ticketing system. So basically, for enabling the use of the app, the users can insert their ticket, and then use the ticket information for entering at the gates. So we also realized an integration with Ticket One, that is the ticket sale provider for Pompeii. And well, the information available are the user one. So there is the map, there is the information about the point of interest with pictures, description, and so on. There is the opportunity to share feedbacks with the park, not the feedbacks that the user feedback about that you can leave on Play Store, on Apple Store, but feedbacks that are used internally by the park administration to understand how they can improve the experience of the tourist. And also, of course, well, the social staff for sharing the experience through the social channels of the Pompeii. Of course, along with the mobile application, we implemented also some features for the administration of the park. So basically, while the mobile user, so the tourists, would like to see how they want to get information about the tracks, the point of interest. The security staff instead want to know, especially during the pandemic, how many people were there, how many visitors in total, how many visitors for a specific track, and so on. So all this information were also available to the administrative staff using through a backend web application that was used by those guys for monitoring the situation and taking the proper action if required. So as you can imagine, the mobile application is just what the tourists see, but everything was enabled by a platform that was completely built on OCI that exposes all its features through API. So everything is a public API available through the internet that are invoked by the mobile application to fetch all the information required for the mobile application. So for getting information about the tickets, the available visits, get the information about how many people are on the tracks, and so on. So we used a lot of Oracle Cloud Infrastructure Services, where, of course, as you can imagine, also for our topic, one of the main one was the OCI IP gateway, that basically was the door, was the gate in front of all of the platform features that give access to all the implemented the API that were implemented, and we implemented those APIs using several technologies. We used containers with deployed on Kubernetes, but we also used a serverless approach with Oracle Functions. And then, for example, we also exposed some of the cloud native services endpoints through the API gateway to enforce additional stuff like authentication. Then, of course, as you can imagine, as part of the solution, apart services like Kubernetes engines, functions, the API gateway, we also have the autonomous database, where we stored the information about the visitors, the visits, and whatever. But the most important stuff that we stored there was the GPS data. Basically, we track the position of the users, and then we use the spatial features of the Oracle database to understand how to get insight about the density and the traffic within the site. So let's share something about the high-level architecture of the platform, and then I would like to spend some words on the API gateway and how it helped us during our journey. So as we said, all the features of the platform are exposed through a set of APIs and by the API gateway. Then the mobile application just interacts with the API gateway for calling the right APIs. As we said earlier, the APIs were developed mainly as microservices that were deployed within an Oracle Kubernetes engine cluster. And the nice thing is that, well, also the microservice implementation has been done using an Oracle promoted library that is completely open source, that is Helidon, for having using a reactive approach in developing APIs. But the other stuff that was really important for us was the fact that, for example, for using the Oracle function and the API gateway together, we were able to modernize the integration with Ticket One, because that provider for shared some APIs for fetching information about the tickets, but those API were in our SOAP web services, so they were XML. Of course, as you can understand, for a mobile application that would like to use REST APIs, dealing with SOAP web services is not the best choice. So we decided to wrap those SOAP web services using a function that then did some kinds a bit of integration and then replies to the with some JSON data. So rather than deploying a full set of API and deployed it within the Gueury cluster, basically we decided to use a serverless approach because the functionality of fetching tickets was something that was required just at the beginning, just to import your tickets, then is not used. So to keep down the cost, we decided to use the function. And the great thing is that the API Gateway supports both the standard, the Kubernetes deployed containers, but also function as a backends. So, and it enables us to implement those in both ways. Of course, one of the things that helped a lot us during the development was the use of the adoption of stock responses, because basically, as you can imagine, when we started to deploy the platform, that we did it in the first release after 6 weeks, we started to define all our APIs in order to enable the mobile developers to know, okay, those are the APIs that you can use for fetching this information or that information. But at the beginning, we had the whole specification, but we had no implementation yet because we were struggling with, infrastructure provisioning and development. So using the stock response of the API Gateway helped us a lot, because basically we imported the Open API specification within the API Gateway. So we create the configuration that to use, and then for enabling the mobile developers to start using the API, understanding how to integrate it and so on, we created mock responses using the stock response features of the API Gateway, and that was really helpful for us. Then, of course, when we started to have some implementation ready, we switched to the real implementation. Then another thing that for us was really helpful was the fact that all the configuration of the API Gateway can be completely automated, as you can see later also in the next session that will be held by Marc. Because of course at the beginning, we were in a hurry of development, so we created we imported the API, we started to configure the first stuff, and we started to use the API Gateway. Of course, as you can imagine, and you know better than me, it may work at the beginning, but for example, we cannot follow this approach when we would like to move the API from a development environment to test and production environment. So the great things of the API Gateway, like other OCI services, is that you can automate the creation, the configuration of the API Gateway using different tools. You can use USACLI, you can use Terraform, and the nice thing is that even if you started manually, so through the console, that is the most user-friendly tool that you can have. The nice thing is that you can export the configuration that you have in the API Gateway, in order to then customize it a bit in order to make it applicable also to other environments. So it was exactly what we did for the development environment. Basically, we created almost everything manually. Then for starting moving to test environment and production environment, we exported the API configuration that we have done in development environment. we modified it for the target environments we were interested in, and then using a combination of the OCI or Terraform for the production environment, for example, we were able to have the same configuration in all the environments, and that for us was really important because, of course, well, as you can imagine, moving things manually is a mess. It's totally error prone. Just to give another light about how the API were implemented and how much was important the CIP gateway role. Of course, since those API are public, exposed by a public CIP gateway, and the information that you are going to share are quite personal, because at the end you are going to share not your name, because we just share exchange things like IDs, so the ticket identifier, things like that, but you are also sharing your position. So we have to be sure that only specific who is authorized to use the APIs can do. So all the APIs were protected through using a JWT token. And the nice thing there was that the OCIP gateway has a built-in authentication method that support the basic authentication that, as you know, is not really safe, and JWT token. So basically, the mobile application internally, when the user logins, issue a JWT token that then is used by the application itself to access to the API. And with just some lines of configuration, the OCIP gateway can be configured to validate a token before enabling access to a specific API. And the access can be done in several ways. You can just say, okay, let's assume that this is issued by the right identity provider, or maybe you can also validate some custom claims in order to enable or not a specific operation that API. And for us, this was really helpful, because again, without doing any specific activity, we were able to enable the authentication on our APIs. So that's the experience that I would like to share. I wanted to share with you, not only about the Pompeii use case in general, that is is a quite complex cloud native application, but was about the role of the API gateway in the success of this application, because as we said, it's the gate to the platform services, and is used with success from months now, because now we are live from more than a year without not on times really, and everything that was also the auto scaling stuff was shared properly with thanks to the integration with the other cloud services. So I hope you enjoyed this session. Now I leave the word to Marc, that is going to show you some automation that you can do with the CIP gateway, that is basically something like we did also for Pompeii. Marc?
Okay, so thank you, Claudio. Do you hear me correctly?
Yeah.
Okay. So you should see my screen. I think that's working.
Yes.
So yes. So hello everybody. So my name is Marc Gueury. I'm working for the Oracle EMEA team for application development, and I will give you a demo about exactly what has been done by Claudio during the development of the Pompeii application. And so what I will mostly do is I will give you three small demos about API gateway. And the first one will be a completely manual one where I will go inside the user interface and show you how to use the product. But then I will go to what they used practically when doing the real implementation is by automating the creation of the APIs and the maintenance of these APIs. So my first demo, I have shown a small architecture here just so that you understand what my demo will exactly do. But typically for this kind of scenario, where we have to expose some APIs from the internet, and in this case from a mobile application. So your mobile application is running on the internet, and before to reach your API, often you have a single sign-on system to allow you to log in, and maybe a web application firewall that is there to protect you for the bad people trying to make your site down. And then you are coming to your private cloud, and in this case to the API gateway. And the API gateway, what it will do is that it will be a website or a URL that will route all your requests to several backend systems. And the backend system can be or a database directly, or a virtual machine, or a serverless function, or a container running somewhere, for example, in Kubernetes. And to be sure that you understand what my demo is about, that is the exact vocabulary that I will have inside my demo. So so I will have in fact a gateway that is already in fact created, and so the gateway is a website that has a particular URL, right? So that is the gateway, and that gateway will have several routes to several APIs. And so for a URL here, it will match an API that is running on a backend. So that is a route. And you can have a group of routes, and this group of routes are called the deployment. So gateway, that is the website, route, that is a URL going to a real API, and a deployment, a group of routes. Okay. So I will try to switch to my browser. Okay, so if I go to my cloud console, what I am inside the Oracle Cloud, where you have a lot of services like a virtual machine, databases, several type of database, but also what we are interested in here about developer services. And inside the developer services, there is the API gateways, right? I have already an API gateway that I will show you how I created it, but I created it with Terraform, so that will be part of my third demo. And so my API gateway, it's something that is completely and fully managed by Oracle. So only things that you really need to do when creating that API gateway is give a name, telling if that is a public API gateway with a public IP, and so reachable from the internet, or a private one that you use with private IP and maybe even not connected to the internet. And then on that API gateway, I can create deployment manually or via APIs that I will show later. But when I do that manually, I create a deployment. So a deployment is a group of routes to real APIs. And so I will call this one API days. I will give it a name, a path to the API days URL. That is not the goal for this demo, because I will not add authentication and course because that's not the goal of this demo, right? So, and I will go to an API that is giving the list of the street of Pompeii, that is our use case of today. So then here I click next, and then my deployment is a group of APIs. So I will choose street as the path. I use the get method to reach my API. It will be an HTTP call to get my API. And then I call the real API that is running on the backend. And so, in fact, what I just did is running some wizard to create my deployment. So it should be ready in some seconds. So if I copy paste what I just did. So now I have in front of the URL, the gateway, in fact, the gateway, and if I type enter, so it's already done. So it has been deployed here, and so when I go to my API gateway, it's giving me the list of the streets. So that's quite easy. That's nice when you have one or two APIs, but practically you never got one or two APIs when developing. So often what is happening is that at the beginning of the project, to use a tool, it's nice to use the console, but when it's becoming more complex, you have a lot of APIs, and you have also maybe a lot of environment, like a development environment, a test environment, a production environment, and so a lot of things to do if you want to do everything manually. So what is better is to add some automation to create your API. So for example, in this case, I will have API A, B, C, and D. And instead of to create one API one by one, I would like to create all the APIs in one shot. And I would also like to be able to redeploy exactly the same in development, test, and production in exactly the same way. Okay, so for doing that, I will show you two small demos. Yeah, two small demo. But first, to give you a picture of how and why it will work, is that so it's part of our cloud solution, and for each component of our cloud, there is always APIs and REST APIs that are allowing to modify or create or delete things that are inside our cloud, like create a virtual machine with APIs, delete a virtual machine with APIs, but it works for everything, containers, database, whatever, and also for API gateway. And so we have this REST API to modify, create what we have inside the cloud. But the REST API, like you know, are not always super easy to use for a developer point of view, because you need to know the right URL to call that API, and to call that API, you will probably need to put a big payload with a lot of parameters inside that payload that you need to learn and get the right format. So that's not so easy. So even if this API are available, we have built several additional tools to make it easier to use. So first, and that will be my demo 2, I have a command line interface where I can just run some commands to create, for example, in this case, an API gateway or modify it. There are also software development kits that are allowing you to create, modify, and delete things inside your cloud, but that can be used for programming language like Java, Node.js, Python, Ruby, .NET, and so on and so on. So we have a lot of development toolkits that are doing exactly the same. And we have also infrastructure as code tools, and that will be my third demo, where I will show you how to use, for example, Terraform to create an API gateway. And we are supporting a lot of other infrastructure as code tools like Ansible, Puppet, and so on and so on. Okay, so for my second demo, what I will show you is the use of the command line tool, and that command line tool is called OCI. So the documentation is here. You don't have to take care about all the parameters. Only the yellow part is the things that could interest you. So in fact, each time that I will use my command line interface, it's always the name of the command line, it's OCI. Then I need to give the family of product that I will use, for example, in this case, API gateway. And then I give the type of object on which I would like to work with, so gateway. And then I can do create, or I can do update, or I can do delete, or I can do get to get information. Then the gateway, that is the web server, but I can do the same for the deployment. So the same OCI command with the function family. Then I would like to create a deployment, and I can also update, get, delete, and so on. And for example, this is to get detail about the deployment. Okay. So I will do that now for true. Okay, so clear. So here I am inside a computer where I have installed my command line interface, and what I can do if I can run some command to get what is happening inside my cloud infrastructure, right? So here I will run a command, that OCI command, to get the list of the gateway that are available inside my server. And so when doing that, it will give, and that is because of automation, it will give something that is readable for a machine. It will give me the definition of my API gateway. And then if I want, I can also create a lot of API with just one command. So if I take that file and I show it. So for example, if I create a JSON file like this, where I say that when I call my API A, I will go to my backend system that is called A. I've not put any security here to make it easy. And if I go to the API, to the URL B, I will call my API B, and to the URL C, I will go to my API C. So if I want to do that, what I can do is I can run a command like this one. So the same than before. So I will use the API gateway family and create a deployment. And so it will take some seconds before that it's done. So if I come back to my browser, yeah, you see that my browser has detected that that deployment is being created. Okay, so it's not done yet. Let's wait. So what it is doing now? Like I am using that JSON file here, and it will create a deployment, so a group of routes. So it will create 3 routes to my 3 APIs that I have here above. And so he has done that, right? So I have here an identifier. So I'm just continuing here on the command line, and what I will store my ID to use it in the next command. So yeah, I export my deployment ID, and based on that, I can run more command line commands, like for example this one, where I will get details about my deployment. And then it's giving me a lot of details, right, about the fact that he has created 3 APIs, so A, B, and a C. But like you probably know, right, when you have such a JSON file, you can have a lot of tools to parse them. So for example, you can just run a command like this, where here I'm getting back the URL to go to my APIs, and then there are 3 sub URL A, B, and C. So when I come back to my browser, here I open this. And if I go to the URL A, it will go to my API A. If I go to the URL B, it go to my API B. And if I go to the C, it go to my API C. So in fact, I got a very easy way to deploy that with a script. So my third demo is about, yes, but what next? Because probably, your whole project will not be only about API and API gateway. We have also a virtual machine. We have maybe load balancer, databases, whatever, maybe containers, and a lot of things. And running a lot of commands, telling I need to create, I need to delete, I need to do this and to do that, that is sometimes quite difficult. So like we do often, and that is the same concept exactly for Kubernetes and containers. It is exactly the same for cloud. Sometimes instead of telling to the system, I would like to do this or to do that, you prefer to define the end state of what you would like to have. And you would like to have a tool that will do the create, delete, update, and so on for you. And Terraform is exactly that kind of tool. So Terraform is fully integrated inside your cloud, and you can do and modify everything inside your cloud based on Terraform. And this is what we call a declarative method. And this has some advantage, because when you have a Terraform file, it's a kind also of documentation of what you have inside your cloud. And that documentation allow you to have repetitive results, because you can take the same file, apply it to from development to test and then to production, and you will get always the same thing. Also, the advantage of using such method is that it's a best practice to put your Terraform files inside a source control, like a Git or Bitbucket or whatever. Inside a source code repository, such that you have a kind of history about all the API that you have created and deployed inside your API gateway. Yes, to do that, I mean, we have a lot of samples, and so if you look on the internet about OCI and Terraform for API gateway, we have a lot of samples to deploy APIs based on Terraform that you can just reuse inside your project. So, but let's say that you have created your Terraform with all the features that you want. How do you use it? So Terraform is some configuration files. And then when you have defined your configuration files, the first thing that you do is you would like to know what the change that you have written inside your code will do. And instead of running and see which error you will get, the first thing that you do is that you try to plan and know what will happen. And so you run the command Terraform plan. And when running the command Terraform plan, it will check what is currently running inside your cloud, what status in which you would like to be. And then it will find, based on that, what he has to do. For example, maybe you have added some new API and it will add a plus. You will remove some API, it will add a minus. Maybe you will do some change on an existing API, so it will change in place. And sometimes if you make too many changes, it will delete the existing resource and recreate it. So it's completely done automatically, and Terraform decide automatically what to do. And when you are happy about that, what you can just do is run a Terraform apply to make the change for true. Okay, and that will be my demo here. So that's that's here. So like you can see, in fact, I'm inside a directory where I have just one Terraform file. The rest is let's say files that are not so much interesting. And that Terraform file is stored inside a Git repository. So, but I have no time to show you that. But you can do DevOps with that, CI/CD, whatever, to make your development better and more reliable. And so if I have a main, if I edit my Terraform files, so inside my Terraform for this demo, the only thing that is really interesting is this. It's the two parts that are here. So the first one is creating or declaring a resource, and a resource is a service, or it could be a virtual machine, and in this case, that is an API gateway. And what I ask to Terraform is that I would like inside my cloud to have an API gateway that will be called API GW, that will be the display name, that will have a public IP address, that will be in my particular subnet because I can define public IP range. And then please create that. If that is already there, just leave it like it is. And then I have also a deployment that I want to deploy inside my called test gateway. Inside my test gateway, I would like that deployment to have that prefix. It will be called like that. And inside that, I will have, and here I have just one route to one single API that is called Terraform, right? And so that is already being deployed inside my system. But what I want to show you is that if I change the Terraform's file, so for example, here I put a 2, right? And I run Terraform plan. It will check the difference that are between what is running in my cloud and what I have inside my configuration file. And then he will tell me, okay, you see, you did a change. Do you want to do it or not? And then if I really want to do it, I just need to do, I'm fine with that. I can do an apply, and it will make all the change I want automatically. So I need to approve that. And then automatically, Terraform will find the right API to call to make the modification of my system. And like you see here, it will not nor create nor delete, it will update that in place. So it will take 20 seconds to do, but I think you believe that it will work. So the goal of my demonstration today is to show you that it's quite easy to do automation. That's even a good practice if you have a lot of APIs and a lot of environments. And that was our Pompeii use case. Thank you very much for your attention. And I think if there is nothing else you want to add, Claudio, that we can finish it here.
No, for me, everything is fine.
Okay, perfect. So thank you very much for your attention. And yeah, goodbye.
Goodbye. Thanks.